Hello guys, if you remember I gave you this worksheet yesterday, right? So I want to go through this worksheet with you now. Can you take it out? Can you take it out? Let's discuss this worksheet together. Okay, now this is basically when you see that this is a question about halogenoalkene, right? Halogenoalkene. And then you use water to hydrolyze it. And then the water, the OH and this will undergo substitution reaction. So let's see what the question is asking. In an experiment, equal amount of 1 chlorel, 1 bromol, 1 idol, okay? And you use ethanol as the solvent. And then after that, you add silver nitrate. So basically what's been doing is this halogenoalkene, the bond, okay? And then the water will supply the OH to substitute the X, right? So, and then you will get alcohol together with X minus. Then the silver nitrate you are adding, okay? The silver ion will then undergo precipitate to form the silver halide. Then by looking at the time taken for the silver halide to appear, you will know how fast the reaction is, okay? So basically, we already discussed this experiment when we were teaching this topic. It's basically comparing the bond length of these three. Do you remember? Since the bond length of a carbon iodine is the longest, so the bond is the weakest, and it is easiest to be broken, then it will take the shortest time for the precipitate to form. So you will expect the questions asking things like that. Why is ethanol used as a solvent? Now, right now, you have an organic compound, you have some aqueous thing. So alcohol is used as a solvent because, as I told you, it contains the hydrophobic and the hydrophilic head. So it can dissolve both the organic and the silver nitrate solution well, okay? So that's why we use ethanol as the solvent. So you can say, because ethanol can dissolve both the halogenoalkene and silver nitrate solution well. Okay? Explain why the apparatus was left for 5 minutes before the silver nitrate was added. Okay, now let's take a look. Like you use the water bath, right? You set a specific temperature for the water bath, and then it takes time for the reaction mixture to attain the temperature you want, right? So, and then I will say we wait for 5 minutes because we have to make sure the reaction mixture can attain the specific temperature, and the temperature is a constant, right? Do you understand what I'm saying? For example, if you set the water bath, let's say 50 degree, then you need to give some time for the reaction mixture inside to reach 50 degree before you start the reaction, because that is why you use water bath, right? So I will say to give enough time for the reaction mixture to attain a desirable constant temperature. Okay? Desirable, the temperature you want, and constant, okay? Do you understand what I'm saying? So that's why, because you need time for the heat to transfer from the water bath to the reaction mixture, okay? It takes some time. Okay, name the precipitate. I told you. Can you see precipitate on the equation? If you use 1 mole, of course you will get silver bromide, right? Because the idea is right now you have this one, and then the OH is substituting this, and this bond is broken. So the Br minus will combine with Ag plus to form AgBr, okay? So the precipitate, the reaction is easy, Ag plus, aqueous, are not required, or you can choose not to write it, but I want to write it. Okay, I want to show you. Now, of course, in the exam, if state symbols are not required and you still come up with the state symbol, it's okay, provided that if the state symbols are correct, okay? But of course, if it's wrong, then marks will be deducted. So you have to read the question carefully. So that's why by measuring the time for the precipitate to form, you will know how fast the reaction is. Predict the order, easy lah, because I already told you the longest bond is aldene, and then bromine, and then chlorine, right? So from the fastest first, so the fastest will be 1 bromobutane, right? And then the second one is the fastest is 1 isobutane, ido, butane, okay? And then 1 bromobutane, and then 1 chlorobutane, okay? Our explanation, because the Ci bond is the longest, and therefore is the weakest. Now you don't have to write so much because 2 marks include this one and this one, so it's the weakest, and you can write it's the easiest to break. Okay, then it's more than enough. Okay, so alcohol usually prepared from halogenic alkene using aqueous, okay, rather than water. Well, this is what I told you lah. Because this one is a stronger nucleophile because it contains a negative charge, but this one is neutral. Okay, name the mechanism and type of reaction. Okay, so it will be nucleophilic, the SN1, SN2 thing, nucleophilic substitution reaction. Okay, now spell it out in the exam. Okay, reaction. Okay, this one mechanism, this one type of reaction. Okay, and then explain why the formation of alcohol is faster when using. Well, this is what I told you, because OH minus is a stronger nucleophile. I think it's more than enough because it's only 1 mark. But you can also say because it contains 1 negative charge, but water is neutral. Okay, so nucleophile are substances that attack the positive charge. If it itself carries a negative charge, of course, it is a stronger nucleophile. Okay, I'll give the mechanism or 1 bromo. 1 bromo, you can draw it out like that. So do you still remember SN1, SN2? For SN1, if it is more likely to happen if the halogenic alkene is tertiary. But for SN2, it favors the primary halogenic alkene. So when you look at this one, it contains 2 hydrogen. So it's primary halogenic alkene, which favors SN2. I hope you still remember what SN2 is. Then we are going to write the mechanism. Okay, and then when you are writing mechanism, I repeat so many times, you have to draw the partial charge, okay? And the lone pair, right now you use OH minus, and then the arrow to show the movement of electrons. So this one will attack this one, and this one will attack this one. So for SN2, you will form a transition state. Do you remember? Transition state instead of the carbocation intermediate. So basically you copy the things. With the dot line to represent a bond is forming and a bond is broken. Originally it's neutral and OH minus carries a negative charge, so it will be like that. And then after the new bond is formed and the old bond is broken, you will get OH plus the Br minus. Understand? So this is SN2. Okay, because it's a primary halogen alkane. 好 next one next one. You can test the alcohol, okay? Test the alcohol with this one and this one. Okay, then what can you see? With this one, if you remember the alcohol group, if it reacts with Cl5 at room temperature, it will form HCl, okay? So the white film will be produced. But for this one, it will be oxidized, right? So with this one being reduced to chromium-free, so the solution returns from orange to green, okay? Describe the result, okay? Which task? Now I will say this one is better because if you use this one, you can only, it is restricted to primary and secondary alcohol. If the alcohol you're taxing is tertiary, then it cannot be oxidized because it's resistant to oxidation. Tertiary alcohol cannot be oxidized. Then it will show a negative result. But right now the question is asking you to tax for the presence of alcohol only, regardless of the degree of alcohol. If you use PCl5, you can test alcohols of any degree. So I will say PCl5 is better because K2Cl07, the acidified one, cannot oxidize tertiary alcohol. Okay, understand? 好，嗱，this one is this one. The question is asking you to show the skeletal formula of the other three isomer. It's easy, right? So this one is the given one. And then the other one should be 1, 2, 3. Mean you can choose the fourth carbon can be here, or the fourth carbon can be here, or it can be like that. 1, 2, 3, 4, right? So the degree will be this one, contains 1H, right? Of course, you don't have to show this one. Contains 1H is a secondary halogen alkane. This one still contains 2H. Don't show the HR, right? I'm just explaining to you. Primary. So the last one is tertiary. Okay, any question? Okay, that's the end. See you.